Hello everyone, my name is Harishini Rajaratinam and I'm from Universiti, Sains, Malaysia, USM. My paper ID number is OCA-06 and the title of my study is The Influence of Breast Cancer Therapy on the Expression of Anti-Neonatal NAV 1.5 Antibodies in the Serum of Breast Cancer Patients. I'm truly honored to be part of this conference. The expression of neonatal NAV 1.5 has been known to potentiate metastasis in breast cancer. The 5' neonatal NAV 1.5 is the splice variant of the LDAR isoform. The distinguishable 7 amino acid changes has been highlighted in figure 1b. The location of the splicing generally takes place at the segment 3 and segment 4 of domain number 1. The electrophysiological changes caused by this alternative splicing would modify the kinetics of neonatal NAV 1.5 channel and thus allow a greater intracellular sodium current to take place. How does this particular sodium current contribute to invasion and metastasis? The influx of sodium current will actually contribute to the efflux of hydrogen ions. The accumulation of these hydrogen ions would lead to the change in the pH, where acidic pH would contribute to the activation of cathepsins or proteases in order to release proteolytic enzyme that is very useful in order to degrade the extracellular membrane and thus ultimately contribute to invasion and metastasis. For breast cancer treatment can be divided into two categories. One is local, which includes surgery and also radiation therapy, and the other one is known as systemic, that includes hormone therapy, chemotherapy, and also targeted therapy. In recent days, a new form of therapy is being included, which is known as immunotherapy. In March 2019, FDA has approved a medication known by the name atezolizumab, which acts as an immune checkpoint inhibitor in order to treat triple-negative breast cancer. This year, a paper was published in the Frontiers of Pharmacology which highlights the functional role of NAV 1.5 in breast cancer metastasis. A particular point caught our attention which suggests that is it possible to make neonatal NAV 1.5 as a biomarker for early diagnosis of breast cancer. We decided to incorporate the idea and propose a new concept whereby we would like to incorporate immunogenicity of neonatal NAV 1.5 as an immunosurveillance marker in order to monitor treatment efficacy. Till date, the discussion on neonatal NAV 1.5 has been restricted to its role in potentiating breast cancer metastasis through studies that utilize breast cancer tissues and also cell line. However, its immunogenicity, which is reflected by the production of antibodies against neonatal NAV 1.5, has not been studied yet, and let alone the immunosurveillance function of these novel antibodies. Let's proceed to objectives. So my main objective is to decipher the influence of breast cancer therapy on the expression of anti-neonatal NAV 1.5 antibodies in the serum of breast cancer patients, followed by 3 specific objectives. So my first specific objective is to compare the expression of anti-neonatal NAV 1.5 antibodies between healthy participants, pre-treatment breast cancer patients, and also ongoing treatment patients. My second specific objective is to elucidate the presence of metastasis via cytokine analysis for each 3 groups mentioned earlier, and followed by the last specific objective, which is the correlation between the first and the second specific objectives. In this study, a total of 96 participants were divided equally into 3 groups, which are healthy participants, pre-treatment breast cancer patients, and also ongoing treatment breast cancer patients. The study took place at Breast Cancer Awareness and Research Unit in Hospital Universiti Sains, Malaysia. The inclusion and exclusion criteria for each group has been included in the slide. The separated serum was subjected to in-house ELISA in order to detect the presence of anti-neonatal NAV 1.5 antibodies, followed by cytokine analysis. Since anti-neonatal NAV 1.5 antibodies are quite novel and therefore we could not find a commercial ELISA kit in order to detect the presence of these antibodies. Therefore, we decided to develop our own in-house indirect ELISA assay. Let's have a look at the results. Based on the comparison made, the pre-treatment group exhibited the highest expression of anti-neonatal NAV 1.5 antibodies, and most important of all, there was a significant difference between the pre and the ongoing treatment group. The cytokine analysis revealed the downregulation in the pro-inflammatory cytokine in the ongoing treatment group, which was marked by the red arrows, and this signifies the interrupted presence of metastases under the influence of breast cancer therapy. In addition, there was a significant positive correlation between anti-neonatal NAV 1.5 antibodies and interleukin-6 in the pre-treatment group, followed by a significant negative correlation between VEGF cytokine and also anti-neonatal NAV 1.5 antibodies in the ongoing treatment group. In this study, we found that the presence or the regulation of anti-neonatal NAV 1.5 antibody is consistent with the presence of metastasis in the pre-treatment group, and such scenario is completely reversed in the ongoing treatment group, where the downregulation of these novel antibodies suggests the treatment efficacy or the influence of breast cancer therapy. The consistency in the expression of anti-neonatal NAV 1.5 antibodies and its significant correlation with well-known cytokines highlights its potential as an immunosurveillance marker. Therefore, such functions should be exploited in order to monitor treatment efficacy and also to detect early progression of breast cancer. As simple as using blood samples, we are able to carry out such act. In conclusion, the presence of anti-neonatal NAV 1.5 antibodies highlights the immunogenicity of neonatal NAV 1.5, and the expression of these novel antibodies is influenced by the breast cancer therapy. And that's all from me. Thank you very much.